So this is a talk about composing reliable systems with virtualization and the Yocto project. And Christopher and I have been interacting and collaborating for a couple of years. So I'm Tim Orling. I'm the Yocto project architect at Intel, a longtime contributor to Open Embedded and Yocto project. Christopher, maybe you can also introduce yourself.
Hi, yes, I'm a software engineer and I work on the Xen Hypervisor and maintain the Xen recipes in the meta-virtualization layer. And I am a contributor to the OpenXT project.
All right. So we're just going to talk about why virtualization. Christopher is going to give you a pretty good deep dive into the Xen Hypervisor. And I'll then take over and talk about the KVM hypervisor. We've got some additional material that I'm going to go ahead and put into the slides, but we're probably not going to cover it today. Some stuff about Acorn and Secure Boot and a few other goodies. But so I think Christopher, I'm going to keep driving, and I'll just let you. Well, sorry. Let me go to the next couple slides, and then I'll let you drive once we get to, or let you speak once I get to the Xen. So all of the content that we have here and the slides will get uploaded here as well is on GitLab. So everything we're going to be showing is actually being built and done through continuous integration, on YP Dev Day virtualization. It's a little bit out of sync right now because I've been doing some stuff today that's new. So why do we want virtualization, right? Well, our premise is the vendor kernel is dead. It hasn't been working. Greg KH is really famous for talking about evil vendor kernels. And what we're thinking instead is run with virtualization and then secure your vendored kernels if you really have to do it in a virtual machine or through virtualization. So why, right? We want to use the latest stable kernel. This is the best kernel that we as a Linux community have, right? And this could also, exclude Linux distribution kernels. They may be better than a raw mainline kernel. But their thing is that you're getting security fixes, bug fixes, new features, the latest drivers, right? And this is the reason that every single vendor out there, you should be upstreaming your changes because everybody can just get it off of mainline. Oops, I forgot to leave that. Anyway, so yeah, this isn't what I wanted there. So why else, right? We want to ship images where we have complete control over what we're shipping. So with Yocto Project, we have complete control over all the contents, the versions of everything, and all of the licensing and license compliance, right? So then you can run your applications in an isolated environment on top of this base image that you ship. You might not even ship any binaries that are actually the applications to your customers. They might just download it themselves. And then you can run vendor kernels and vendor images in virtualization. So with that, I'll let Christopher start talking about the Xen hypervisor. And we forgot to change the date, sorry.
Thanks, Tim. Okay, so I work primarily with the Xen hypervisor and have done for some time. And it's a mature open source hypervisor that's been used in production for many years now. It's a project under the Linux Foundation at this point, and it has this structure that hopefully you can see in the slide here, where there's in the Xen software you have the hypervisor itself, but you also have a set of tools providing management of virtual machines on your platform, and it allows, on x86 platforms, allows you to run standard Windows virtual machines concurrently with Linux virtual machines. There's device drivers for the Xen hypervisor that are upstream in the standard mainline Linux kernel. and it allows you to basically do the familiar, if you're familiar with virtualization, you know, dynamic creation and shutdown of VMs independently of one another. It's a powerful set of software. Okay, and the key thing with using virtualization is that the software within these guest virtual machines are strongly isolated from one another. There are narrow, well-defined interfaces to the platform, and guests are contained within their virtual machine. Next slide, please, Tim. So I'm working on the OpenXT project. We leverage the Xen Hypervisor to do isolation of components that you wouldn't normally confine in this way, but you can when you've got virtualization available. So we moved the network device driver into its own domain, supported by a Linux kernel around it, and that provides network service to the other virtual machines on the system, thereby meaning that if there is a flaw in your network device driver, that the opportunity to cause disruption because of that flaw is contained to just the network device driver domain. So you're leveraging virtualization for strong isolation, and you'll see similar features adopted in virtualization-based security in Windows. It's a mature architecture at this point. Next slide, please. So this is a more recent development for the Xen Hypervisor. So this is a bit of a retrospective of some work done this year within the Xen community, and introduced into Yocto. Basically, we're looking at can we get the Xen Hypervisor up and running on a modern Raspberry Pi 4? Let's have a go. So what we have, the ingredients for this is we're going to use the Xen support in Yocto in the meta-virtualization layer. We're going to add the Raspberry Pi 4 hardware support from the Meta Raspberry Pi layer, and we'll use the Pocky standard Yocto Linux distro with the Meta open embedded body of standard software. And in order to glue these pieces together, we're going to add in an additional patch series to the Linux kernel to enable this support. And the patch series went into meta-virtualization, and with the upstreaming of those patches into the upstream Linux kernel, the patch series then came back out of meta-virtualization. So that was progress in the last few months. And then in order to run the build, we set a few standard configuration variables per standard Yocto build. We're going to set, say, the machine that we're going to build with. We're going to turn on the distro features for virtualization in Xen, set a couple of fields in order to speed up the QEMU build, and run a standard bitbake. And so when you run bitbake Xen image minimal, it proceeds all the way to the end and out pops an SD card image suitable for writing to your SD card and booting your Raspberry Pi. So what's actually on that SD card? So we've got two partitions. The first one contains the hypervisor, the DOM0 Linux kernel, some standard device tree for the Raspberry Pi 4, which is processed by both the Raspberry Pi firmware and the Linux kernel, and some other small pieces for the bootloader. And then in the other partition, you have the standard Linux file system, which is the root file system for domain 0. It's got all of the standard open source Xen tools, but it doesn't contain the hypervisor. The hypervisor and DOM0 Linux kernel are actually on the boot partition. It's a slightly preferable layout because you don't necessarily need those things available when DOM0 is running. So it's better to put them on the boot partition. Okay, so when we launch, this is what you'll see if things have gone well and you've got a SD card that's healthy, and all the way through to complete boot. It's a little underwhelming, but actually it's highly reassuring to see this as a console message rather than frequently hypervisor engineers see much more exciting log messages than this. But this is good. So when you log in, it looks just like you're interacting with normal Pocky Linux boot, but actually you've got the Xen tools as well. So what we're seeing here is using the XL standard Xen command line tool to list the running domains on the system, and you can see domain 0 with a 256 megabyte memory allocation. It's got 4 virtual CPUs. Everything looks healthy. So there you go. That's success. So to get slightly more exciting evidence of what's going on your system, you can get for yourself one of these USB serial things from a popular auction site. And so this plugs into the USB port on your laptop or nearby desktop machine, and you plug those 3 wires that you see hanging off the other end onto the pins off the Raspberry Pi 4. Actually, Tim, if you can move to the next slide. There we go. So it's these particular pins, and then you turn the power on your Raspberry Pi 4, and if you're running Minicom on your laptop, you can watch all the serial messages as the Raspberry Pi 4 launches, and that will give you, the startup of the hypervisor and the transition all the way into Linux and DOM0. So I think if we go to the next slide, Tim, I think we've got a video, if that will play. Here we go. So takes a little bit for the, here we go into the bootloader. And you can see it's loaded Xen. It's got a slightly different device tree than standard Linux to put things in the right place. And there we go, all the way through mounting the root file system. It's getting a IP address on the network, and there you go, all the way to the root prompt. Thanks. Okay. So once you've got Xen up and running, again, the standard Xen functionality you might be familiar with from other Xen systems is available. You can see what VMs you're running. You can query info about the hypervisor. You can examine the Xen store state and look at the kernel messages and the Xen boot messages, all standard stuff, and all now working on the Raspberry Pi 4. So once you have a hypervisor on the Raspberry Pi 4, the next step of interest is to get yourself a guest virtual machine to run. So again, there is a image recipe in the meta-virtualization layer for building a guest operating system. And so it's configured differently than the host. There's things in DOM0 that you don't need in the guest. There's drivers in the guest that you don't need in DOM0. So anyway, so you just bit bake the Xen guest image, and it will insert the correct pieces. And the output of that you'll have a file system that by standard, the default will be to produce an ext3 file system that you can then use for launching the guest. So you'll need the copy of the file system and the guest kernel image and a config file in order to tell the tool stack where those pieces are. Okay. So in addition to that, there's a little bit of preparation you can do to DOM0 on the host to enable networking functionality within the guest. So this is a sequence of steps that will create a new bridge in DOM0, and it will move your Ethernet device onto that bridge, and it will shift DHCP over to the bridge from the raw interface. And then the second step, as preparation for launching the guest, is to make that ext3 guest file system available through a loopback device. It's a little cheaty to do this, but it's definitely convenient. Okay, so this will show launching the guest from domain 0. So we're using SSH to access the host from the desktop machine coming in through the network, and then we'll run the command to actually create the guest, and we use the -c argument in order to follow the serial port as the guest starts, the virtual serial port of the guest. So you see here all the Linux boot messages as the guest is starting. This is a standard Yocto kernel built for the guest, and there you can see that the guest itself has got its own IP address from the network there. And then we just power off the guest, and it shuts down cleanly. And you can see that the guest is no longer running. Okay. So this is a description of some of the work that was involved in the new patch series for Linux to make Xen on Raspberry Pi work. So this was some of the work done in the Xen community to enable compatibility between the Raspberry Pi 4 hardware and domain 0 for Xen. In order to bring this into Yocto, we used some of the more novel aspects of bitbake and layer functionality. So we used a dynamic layer inside meta-virtualization that only activates when you're using it in conjunction with Meta Raspberry Pi. And then within that dynamic layer and that extra set of recipe additions, you've got the patch series that modifies Linux for Xen, which is now upstream, and that's come out again, no longer needed in meta-virtualization. There's also some customization of the bootloader script so that it loads the Xen Hypervisor binary. By default, the U-boot bootloader would just load a Linux kernel, so we have to add a script to launch the hypervisor first. And it sets things like the DOM0 kernel command line, which has got some Xen-specific settings, not typically there for standard Linux-only boot. We had a config for the Xen Hypervisor uses kernel configuration, kconfig, similar to the Linux kernel. So there's a file in there with the right settings for the Raspberry Pi 4 hardware, and some other small additional pieces. I think that's all I want to talk about on that one. So I just want to give some other pointers to other hardware that you can also use Xen with via meta-virtualization. There's so you can build Xen for a standard x86 platform. There's integration with Yocto's WIC tool so that you can run this command. It will generate from the Xen image minimal, which is the host Xen image. It will generate a single file that you can just DD to the front of your disk to boot. So it has the partition layout and bootloader configuration just to launch straight into Xen, nice and easy. There's another piece of hardware that people in the OpenXT community rate as suitable for Xen development, which is the PC Engine's APU2. It's a little small device, but good open hardware and has support for dynamic routed trust for measurement. If you're interested in that, I would point you towards the OpenXT community to come talk to us. And then a final way of launching Xen in meta-virtualization is to actually use QEMU. So the bitbake run QEMU command, you can launch the Xen image minimal, and it will launch Xen at your command prompt. I'd say this is pretty experimental. It has worked. It's kind of stretching both QEMU and Xen a little bit. So maybe in need of a little bit of love. It might depend carefully on which machine you're launching or which exact version of Xen. But that's a thing that there's a few of us interested in polishing a bit and making
and
generally. Sorry, Tim, go ahead.
It's also interesting because you can do TPM in QEMU now too, and so there's a lot of really interesting things you can do without having to have that hardware, quote unquote.
Gotcha. Yeah. Okay.
I think that's it for that part. So I'm going to take over here and just talk a little bit about some of the new things we've been working on for this round behind the scenes. So it'll come to no surprise to many of you, but I use costs a lot for what I call the manifest and configuration. So manifest meaning what layers am I using, and configuration meaning, you know, what am I doing in local.conf and things like that. And the other thing is to show off an approach of using multi-config to build the host and the guest images at the same time, right? All in one step. This is still a work in progress. So, you know, we're gonna have to update it to be exactly what we want, but it actually works and builds the image. It's just not quite as functional as we want it to be just yet. So there's a lot of stuff here. I put all of this material here just so that people can go back later and look at the slides. I'm not going to cover everything, but costs basically is a tool that came out of Siemens, even though it's not a Siemens specific thing in any way whatsoever. And essentially it just lets you lay out in YAML what your configuration is and what your layers are, right? So it's got certain things it needs this header, but here you can set your machine, you can set your default target, you can set your default distro. And then you can start adding your repos. And one of the interesting things is it has this meta custom. So this isn't an actual layer. You're not actually naming or creating anything. This is just what's in the repo that you are running costs from. And so in that repo, you might already have a conf layer and, you know, conf multi-config and things like that. And all of that will just automatically get picked up as this, you know, meta custom entity. And then you can start specifying the other repositories and layers that you're going to use. So here you can see we're picking up Pocky and, you know, where we're getting it from. In this case, we're just going to grab master as the ref spec. So ref spec could be Dunfell, or it could be a very specific commit hash. So you can completely control exactly what you're cloning. And then you can, in the case of Pocky and some other layers like meta open embedded, you've actually got multiple sub layers. And so you can specify all of the layers that are being added. And then we can add meta intel, meta open embedded, another example of multiple sub layers. We can add meta acorn, meta virtualization, meta cloud services, meta security. So one of the things that might be considered a drawback is you can only do your repos in one kind of root-based cost YAML. And so that's why everything is in here, even though we might not be using all of it for the specific build we're talking about. And here's Meta Raspberry Pi. And then you can start doing things with BB layers, right? So this stuff will just get, the stuff under BB layers conf header, this will get prepended to your BB layers file. So you don't have to tell somebody, go edit your BB layers or go run this command or that command. Same thing with local.conf. And so in local.conf, we can do our normal things, but here we can, you know, distro features append virtualization, right? So then the next thing is you can actually inherit or include from one file to another. And so here's what we're doing for Raspberry Pi. So we're including the cost YAML file that we were just talking about, but now we're changing the machine to be the Raspberry Pi machine. And now we're adding a target. And notice I'm using multi-config. I wasn't sure if the new MC syntax works the same, so we'll have to verify that. But so this is telling Cos, first I want you to go build the Xen guest image minimal, and then I want you to build the Xen image minimal. And then you can see some other changes. So here, because we're building a whole bunch of different things, I want to change the temperature to be something where it's kind of obvious which build what I'm actually looking at. And then some things about, the image file system types that we're going to add. We're going to append the Xen feature to the distro features. We might want to set the number of threads or parallel make. Might want to change those QEMU targets that Christopher talked about a little while ago. And then there's some extra stuff here. This is what I'll get to in just a second. Talking about this Xen guest that we're going to build. So this is actually work that Ross Burton originally did on the Meta Acorn layer. I changed it from being a container package to a vessel package just because containers is so overloaded in our terminology right now. But basically what these two lines are doing is setting up a BB class that's going to allow it to know where to go grab these things from in order to shove it into the host image. And then you can see I'm actually going to append in the Xen image minimal this Xen guest image minimal package, right? So what this is just a recipe that wraps that image and makes it installable onto the host image as a package, as an RPM or DNF or a IPEC or whatever. So what's that multi-config look like, right? It's really simple. And so this is literally in the YP virtualization layer that we've got. We just set the distro, set the temperature, set the preferred kernel provider. And then in this case, we want a QCOW image. So that's a common cloud format, which is basically directly bootable in theory, right? So this is not working right now. That's why we got the, under construction. We're probably missing the right WKS file or, the WIC Kickstarter file and maybe some other things, but more on that in future updates to the repository. So we've got this this need for packaging something up as a guest that we have built and packaging it up and then installing that onto the host image. And so here we're just defining some variables and some things we're going to use. And we do a little bit of magic with the image name. We set what the vessel dir, where these things are going to be put. So right now it's going to go into varlib machines. More likely we'll probably start putting things into varlib libvirt images instead. Just kind of standardize on the libvirt directories. And so we're going to depend on kernel deploy. We want to make sure the kernel has been completely built, and then we're going to depend on multi-config being done. I've had some comments from other folks that maybe the kernel deploy isn't necessarily needed, but in this case, at least we know we want do image complete. So that means the WIC image has been done, the post-processing has been done, and so on. And then do install, we're just going to create that vessel directory, right? Just in case it doesn't exist already. We're going to, in this case, copy the image. So this is the kernel image because we need that in Xen. And then we're also going to install that, the actual root FS, and hopefully that'll be a QCOW. So this installs it. It just doesn't boot right now. So a little bit of caveat emptor at the moment. And there's just a little bit more. We're inheriting a package group, or wait, I think this is the wrong. I think this is the package group file. Sorry. The title of the slide's bad. Yeah, this was the Xen package anyway. Let me skip over that. So the Xen guest image package, this is calling Xen guest package BB class, which is what the prior slide was meant to be. So the BB class, or sorry, what the couple slides ago was showing. So what we're going to do here is use that Xen guest packaging class just to package up this image once it's built. We're going to go ahead and pre-populate that static config file for Xen and just install it alongside the image. And here's what we're currently working on with the Xen configuration file. So you'll notice that the kernel is going to be in the same directory, this varlib machines that we're using. The console settings, the memory, 256 megabytes, the name of the guest, how many virtual CPUs it's going to have, the serial port. And then here's where the magic is kind of happening. So we're going to use this QCOW2 format. So essentially we're using the QEMU driver stack in Xen. And we're going to load this QCOW2 format, make it into a virtual device, make it read write, and the target will actually be that QCOW image that we're installing. And then finally, we need to have the virtual network interface set up. So at the moment, we still need to use the bridge control, BRCTL, in order to create this Xen bridge device. And even with trying to set up things, in this case, we're using sysvinit. So even trying to set up the interfaces and whatnot, it still needed the device to be created. So we still need to use that BR control that Christopher talked about earlier. So we've got a little bit more work to do here to make this, directly just out of the box work. Christopher, I'll let you go back.
Thanks. I just wanted to give a few thanks to the different groups that have been involved in enabling the Xen on Raspberry Pi 4 support and making it work. So it's been nice to see the collaboration that's been happening between different groups in the Xen community upstream, and in particular the interest from the Eve project, where some of the original enabling patches were first put together, and then the support from the maintainer of meta-virtualization, Bruce Ashfield, for allowing some of the more unusual modifications to the meta-virtualization layer to go in, and respect to Corey Mignard at Monitor Vista for first coming to the list with the proposed set of patches to enable the Xen on Raspberry Pi 4 work with. That was sort of precursor work to what got merged in the end, but it was definitely a strong contribution and very helpful. Thanks to Tim and David for giving us the opportunity to talk at the Yocto Dev Day about this. Also, thanks from me to the OpenXT community for supporting my involvement with Xen and Open Embedded. And lastly, a quick thanks to the Raspberry Pi community for developing and promoting accessible hardware with open source software. It's fantastic. So,
yeah, definitely echo that. I've had some issues personally with Raspberry Pi just because it isn't open source hardware, and I wish it was. But the fact that they keep coming up with these new boards and new versions it's pretty hard to ignore it, and it's very, very popular right now. So. Yeah, so now I'm going to take over and talk a little bit about the KVM hypervisor, and then I'm going to try to go fairly quickly to leave some room for questions. So KVM's just built into the kernel, and it basically just uses QEMU to run it. And what do we need to do, right? So we create a package group that sets up the tools we need. So we need core boot, we need QEMU, we need we're going to use libvirt on the target, or sorry, on the host, right? So, or yeah, the target that's hosting KVM. One of the things we want to add here is actually cloud init, but it isn't ready to build right now. I'll talk about that in a second. So just like we talked about with the Xen, package, we've got this KVM package. But in this case, I thought I'd do something a little differently and show how to actually grab a unmodified binary image and deploy that. And again, this is based on work that originally was done by Ross Burton with Meta Acorn. So here, what I'm doing is I'm setting the base URL. So in this case, Ubuntu, right? So Ubuntu just has this cloud images URL and you can go to, and then you need to know the release. So in this case, focal is 2004. What's the arch going to be? AMD 64, because I'm going to run this on a Intel platform. And then what's the name, of that image going to be? And so it's basically, focal server cloud image, AMD 64 disk KVM image is what the thing is. And then I can set a date if I want a specific build, but they're constantly updating this. And so it's better to just set it to current, and it'll just grab the latest image, which may even be nightly, and then just make that whole thing into a binary that we're going to install. And so here's what the source URI ends up looking like. A little bit of magic to get the SHA-SUM from Ubuntu, and then I've got this function, just to go fetch the checksums and go like hack this into figuring out what the source URI checksum is actually going to be. And since we're downloading this from over HTTPS from Ubuntu, we should be able to trust that checksum. And again, this is credit to the insanely wonderful Ross Burton, who showed me how to do this a few years ago. And then in the last time we talked about this, we didn't really show a nice way to launch. We definitely want to do this a different way, but right now you can basically just call, like you would on your development machine or your desktop, just call QEMU system x86-64 with the amount of memory and the drive. And then here we're going to use something that should look kind of familiar to that Xen format that we talked about earlier. So we're going to grab a QCOW image, and it's at this place, and we're going to run it no graphic because this happens to be a console only image and a console only server image. So we don't need graphics. So with that, this is me just capturing a PuTTY terminal. So you can see here, I run that launch script. So this is me using a serial console to the NUC that's actually running all of this. And now you can see that Ubuntu 2004.4.1 LTS booted. And this doesn't quite get all the way to the login. I had some trouble with the GNOME shell recorder, but it's basically not that exciting because it's just booting. But the next part of this, though, is that the default images do not come with a password. So they come with a default user of Ubuntu, but they don't have a password in them or SSH keys in them. And I'll give a caveat, right? I am not like a cloud person, not really, right? I'm trying to do this virtualization stuff because this has been hitting the edge and embedded very, very hard for like the last 4 years, right? We've been watching this coming for a long time, and multiple people are doing this commercially, but not necessarily sharing it with the community. Okay, so just some future work here. And in the slides, I've actually got a bunch of stuff about secure boot, just some things I learned. I'm not going to get into it. We want to add cloud in it because that's actually how you set the username and password. This is what everybody is suggesting. We want to use Versh to actually use a template to create an XML template. That's how you would normally launch with libvirt, or another launch script that's kind of auto-populated rather than the one I showed you, which is hard-coded. And also a lot of people insert their SSH keys into the guest, and that's also, I believe, done with cloud in it. Again, I'm not a cloud expert. So I'm going to stop there because we've got a lot more material that I'm going to leave in the deck, but that's really what we wanted to cover today. I'm leaving the stuff in the deck because I just figure it's, hey, we're doing this work. You guys might as well see what we're doing and go and then ask us questions on the mailing list. But we've got a couple minutes left. Does anybody have any questions now?